Okay, this is Algebra lesson 8.2b, right? Second day of this, using a distributive property. Okay, to expand on what we learned yesterday, if you end up with a problem that looks like this, 2d plus 6 times 3d minus 15 equals 0, here's the deal. Here's the deal. What this means that we're going to do is this. We are going to, well, I have a question. Let's say I have an xy equals 0. Let's just say I have xy equals 0. First of all, what's xy mean? What is xy? When x is right touching y, what does that mean? X times y equals 0, right? Mm-hmm. So what could be true to make this 0? What, all of a sudden there's two variables here, right? What could be true? What would need to be true to make this statement true? What has to be true? One of them, at least one of them, has to be a 0. Does that make sense? At least one of them has to be a 0, because anything times 0 is 0, right? So the x could be 0, and no matter what y was at that point, it would be true, right? Or y could be 0, and no matter what x was at that point, it's going to be true again. Does that make sense? So remember, this equal sign here is not asking you if something is equal to 0. It is telling you that something is equal to 0. Remember, this equal sign is telling you that this thing equals 0. So what that is telling you is this. Just, instead of it being xy equals 0, it's these two big things, right? It's those two big things that is being multiplied together to make 0. So then what is true? Let's work this out. What is true about this then? If we know that this times this is 0, so then what is true? What's going to be true here? One of these guys, either 2d plus 6 is going to equal 0, or 3d minus 15 is going to equal 0. One of those two is going to be true. Does that make sense? So then, this is how you set this up. You have to look at this problem and understand what it's saying. You know that either this or this is equal to 0. So what you do is you rewrite the problem. And you rewrite the problem very weird. You actually go 2d plus 6 equals 0, right? What is 2d plus 6 equals 0? Minus 6, 2d equals negative 6, divide by 2, d equals negative 3. So if d was to equal negative 3, and I was to put it right here, what is 2 times negative 3? Negative 6. Negative 6 plus 6 is 0. That would make, so this whole thing, d could equal what? Negative 3. Does that make sense? It could equal negative 3. So you put down d equals negative 3. And then, oh, but wait a second. Couldn't this also equal 0? Right? So then we would actually come over here and go 3d minus 15 equals 0. Plus 15 plus 15. One second. That would be 3d equals 15. What is d equal to here? 5, right? So then here's how you would answer it. D equals negative 3 or 5, and there's your answer. It's both, right? Because it's not both. It's either, right? It's either one. If d was to equal 3, it would work, or if d was to equal 5, it would work. Therefore, d equals negative 3 or 5. Does that make sense? And so the answer here is 2 of them. Does that make sense? Okay, so let's try one. You guys try one of these. See if you can do it. Let's go. I'm going to give you one here. 3x plus 4 times x minus 2 equals 0. I want you to solve that for me. Solve it for me. Now, when you look at this, and you know it equals 0. It wouldn't work.
Let's go, Michael.
It wouldn't work. It wouldn't work if this wasn't equal 0, right? What makes this workable is that there's a 0 there, right? Because then you know that this is going to equal to 0 or this is going to equal to 0. So you rewrite this two problems, right? 3x plus 4 equals 0 and x minus 2 equals 0. There's two equations there. Minus 4, 3x equals negative 4 divided by 3, x equals negative 4/3. That is an acceptable answer. That's what I would leave it as. You guys are in algebra now. That's good. And then over here you go plus 2. Oh, x equals 2. It's either one. So you would write your solution like this. You would literally write down that x equals, and you put them in numerical order, right? So from smallest to biggest, you'd go negative 4/3 or 2, right? Now here's the deal. I'll tell you a little secret about this. I'm just going to show you this very briefly. This is probably like in chapter 9 or 10. But when this answer here, what this looks like, first of all, that's a quadratic. We're going to get to that in just 2 seconds. That's a quadratic. This looks like this. This is going to be a problem that looks something like this. Okay, it forms a parabola. And do you know what these 2 points are? They are where it crosses the x-axis. Okay, that is where it crosses the x. It's called the roots. Now, I didn't draw this correctly at all, but I'm just saying that is true, that one of the roots will cross at negative 4/3, and the other one's going to cross it too. So it would cross, like right here and right here. So it actually looks something like that. Does that make sense? You know what I'm saying? We'll get to that later. Now we're starting to get into some trigonometry, algebra 2, but it does happen. How many of you got that, by the way? Those answers? Okay. Here's the next step to that, and that is you have to be able to do this. What if I have 3n times n plus 2 equals 0? It looks different. But nothing changes. I want to see if you guys can do it. See if you can do it. It's been written slightly differently, but nothing changes. There actually are two equations here. There are two, what do we know is true about this? That either 3n equals 0 or that n plus 2 equals 0. Does that make sense? Could I have written like this? Would that have made you feel a lot better? Probably. Do I need to write that there? No. But do you understand what I'm saying? Like, it's still there. Right? If this n was 0, that would make 3 times 0, 0, and then the other time it would all be 0. So anyway, here we go. This is what you do. You go 3n equals 0 and n plus 2 equals 0. 3n equals 0, divide by 3, n equals 0. There's one of them. And then minus 2, n equals negative 2. So there they are. N equals 0 or negative 2. Right, it would be the other way around. You're right. Negative 2 and 0. Correct. Make sense? Does that make sense? Okay. Try this one then. I like it. This is where things get a little bit fun, and that they start making you do things that, okay, here we go. What about this? 8b squared minus 40b equals 0. Come on now. I'm not going to say anything. Do what you know you're allowed to do. Okay, you're watching. All eyes are up here. Where have you seen something like that? Where have you seen something like that? What might I have asked you to do recently with that? Factor it, right? Factor it, yeah. So what can I pull out of 8b squared minus 40b? 8b. I can pull an 8b out of there. What's that leave me with? B minus right? Does that make sense? Factor it. You're just breaking it apart. You're just making it into something smaller, right? So now all of a sudden, now can you tell me What is b going to equal to? Well, obviously, what's this b going to be equal to? Right? 8b equals 0, and b minus 5 equals 0. This one, divided by 8, b equals 0. And then over here, plus 5, b equals 5. So there they are, 0 or 5. Does that make sense? You had to remember to factor it first, right? You had to remember to factor it first. Did anybody get that? Did you?
I got 5.
Oh, well then you're wrong.
Yeah, I just got 5 too.
Wrong. That's wrong. You got them both? Yeah, you have to remember to factor first, right? Because it's 0 or 5. If it was 0 or 5, it would have still been. Okay, what about this? One more baby step. What if I had this guy right here? Now this is important. What is the thing that, so far in today's lesson, every one of these things, what does it have to equal in order for you to be able to even do this? It has to equal 0. So, you know what you're allowed to do to equations. Do it. You can do anything you want to an equation, as long as you do it to both sides, right? Okay? This thing needs to equal 0. Force it to equal 0 right now. Force it to equal 0. Just do it. You can do it. Are you done, Bravey? Are you? You forced it to equal 0? Good. Okay, here we go. You're watching. You're watching? For real, watching. This doesn't equal 0. So to make something equal 0, what does that mean I have to do? Just clear the house out, right? Just clear the house out. One side, right? Clear one of the sides of the duplex out. Let's get rid of this guy. Let's clear him out. How do I get rid of 3c? Minus 3c. Minus 3c. This is now equal to 0 over here, and I have c squared minus 3c. Right? Okay. What can I do with that baby? Factor it. What can I pull out? A c. I'm going to pull a c out of there. What is c squared divided by c? C. What is negative 3c divided by c? Negative 3 equals 0. What are my two things then? This c is obviously going to be, and look, you get to the point where you can look at this and see. What is going to make this equal 0? What is that c going to be to make that be 0? 3. What is this c going to be to make it, 0, right? Does that make sense? This one just is c equals 0. So the answer is c equals 0 or 3. Did anybody get that? Does it make sense? Make sense? Try one. You're watching again because, he's going to make sure you got it, and then you guys, I'll set you free. First thing we do, line on the equal side, always, and you go, okay, is oh man, what a mess, right? This is a mess. In order to do this, there's a quadratic here, it's just a mess. You got to get the variables on the same side, right? I mean, like he's been split up and he's being squared and all that good jazz. And so let's just clear out one side, make it equal 0. Add 10x, add 10x. This side is now 0. Good, that's exciting. X squared plus 10x. Agreed? Now what do I do with this thing? Factor it. What can I pull out? An x. That leaves me with x plus 10 equals 0. Right? And now you can make the two equations, x equals 0 or x plus 10 equals 0. Well, what makes, that's done, right? Minus 10, x equals negative 10. And you can go in there and look and go, okay, well, what would have made that 0 anyway if x was negative 10, right? So anyway, the answer would be x equals negative 10, comma 0. How many of you got that? Negative 10 and 0. Does it make sense? Does it? I hope so. I hope so. Really quick, I'm going to show you one more time how to group again. I'll do one of these grouping ones just so you can see, so you can be reminded. 2nu minus 8u plus 3n minus 12. You look at this thing, what's the first thing you do anytime you see it and you see it says to factor? What's the first thing you do? See if you can pull something out of the whole thing, right? See if you can pull something out of the whole thing. Can I pull something out of the whole thing here? No. So then you start grouping these babies, right? What can I pull out of this guy? 2u. So I'm going to go 2u times n minus 8. And then over here, what can I pull out? 3 plus 3 times n minus, oh, it wouldn't be 8, it's a 4. Thank you. 4. N minus 4. And you go, ooh, wait, ooh, awesome. They look identical, right? Since that's true, what can I now pull out of this thing? I'm going to pull out an n minus 4, and that leaves me with 2u plus 3. Remember? We did this yesterday, remember? Okay, the only other kind there is sometimes they make you do this. I'm going to show it to you, 16gh plus 24g minus 2h minus 3. Nothing, I can't pull anything out, so group. Pull this out, so that would be 8. I'm pulling out an 8 here. Ooh, yeah, okay, I'm pulling an 8g, so 8g. And that leaves me with 2h plus 3g plus 3, right. And then over here, what can I pull out of this? Pull out a negative 1 times 2h plus 3. Does that make sense? You pull out a negative 1 anytime you need to. Now they look identical. Pull out 2h plus 3 times 8g minus 1. Make sense? It looks complicated. It's not. You guys now know how to do this. I think it's no problem. Okay, let me give you your homework. It is not as short as, but yeah, I'm giving you 14 minutes to work on it. I should probably double it. I should. We're going to go page 480, 15 through 44 even. Okay, page 480, 15 to 44 even. 15 problems, that ain't nothing.